Shall we start, sir?
Yes, sir.
Yeah, sure, sir, sure. Yeah, good morning again. Just in our last session, we have we have discussed about the power electronic controllers for wind energy conversion system. So I just started by discussing these two topologies. In these two topologies, in a permanent magnet synchronous generator and school cage induction generators, we have to use the power converter ratings equal to the machine rating, and synchronization issues will be taken care by PLLs of the grid tied inverter. So that's what just we have discussed. Then just we have moved to these two topologies in the bottom of the slide. So in these two topologies, normally people use the slip ring induction machines for this wound rotor induction generator and WF induction generator. So here, if you are looking at the power converter ratings of these two topologies, it's a 30% as compared to the previous two topologies. Why we say the power converter ratings are 30% means here just we are accessing only the slip power at the rotor side. So only you are handling the slip power. So if I say it's a slip ring machine operates at 20% or 30% slip, then your converter at rotor winding also will handle the 30% or 20% of the power. So that's what the power converter rating in these two topologies are 30%. So here the advantage of having a 30% power converter rating is we can say even if you reduce the 5% rating of the converter rating, then that will give the huge impact on the cost of the system. So that's what here just almost we are reducing the 70% converter rating. The cost of the system will reduce drastically. That's a major advantage with these two topologies. So that's what even nowadays people are in an electrical system, people will talk about WF induction generators in most of the cases. So the only drawback with these two systems are just you have to problem with the machines, because just we are using the slip rings here. So the somehow just you have to go with the maintenance. That's the only drawback with this system. Even if you take any system, there are some limitations. So for this also, this is the limitation of this system. So I cannot say this one is superior than any other thing. So depending upon the application, depending upon the condition, just we have to design the proper system. So no system is perfect in the world. Even we can say any system, even your I should not say even our organization or in your home, just the system we have to design depending upon the condition. So no system is perfect in the world. Even no one as an engineer, we should not claim this is the best in the world. Nothing is best in the world. So I mean, it's depending upon the condition. So the same way, this WF induction generators also is having the advantages depending upon the condition. So where means in a wind energy conversion system, when we are going for offshore power generation, so this DFIGs are the better candidate, right? So here that's a major advantage as compared to this previous two topologies. But here, when we compare to these two topologies, it is the wound rotor induction generator. It's kind of a rotor resistance control method for in a electrical drive. So here we are using this rotor resistance control method in a power generation. So here this WRIG just I mean, if the machine act as a generator, we need to short circuit the rotors, rotors, then only just your circulating current will flow. So in this case, that rotor coils will be connected by using the power electronic converters. So here, depending upon the duty ratio of the chopper, so the duty ratio can be decided by the controller. So in the controller, just we are having the duty ratio control as well as maximum power point tracking. So by using that, just we can able to just we can control this chopper. But here in the chopper, just we are having the single switch. So single power electronic switch means just we need the control is easy here. So by controlling this, you can able to change the rotor resistance value. So by changing the rotor resistance value, you can able to control the speed of the machine. So if you are able to control the speed of the machine, you can able to control the turbine speed, right? So in that way, you can able to implement the maximum power point tracking in this system. Here, the limitation for this system is you can able to generate the power above synchronous speed. So above synchronous speed only, it will act as a generator. So you can able to control the speed in the above synchronous speed to 20% of the slip speed, right? So in that range only, you can able to use this machine as a generator, or this topology works. So, but in this case, double effect induction generator, just we are having the bidirectional converter at rotor terminals. So depending upon the wind velocity, we can able to operate this system in subsynchronous as well as supersynchronous mode. So that is the another big advantage with the double effect induction generator. So for this reason, just we can say we can have the wide speed range. So wide speed range of operation is possible in this case, right? So because of the wide speed range, then your energy captured during this, during the year will be higher. So that means low speed operation and high speed operation is possible because of the wide speed range. So that is another advantage with the double effect induction generator. So here subsynchronous speed, in this case subsynchronous as well as supersynchronous speeds, right? So here already this topology available. So with that, just we have proposed some new topologies by incorporating the battery energy storage in it. So by having the battery energy storage in it, just we can you can eliminate all the power oscillations in it. So that's a big advantage. So here, whenever we are having the excess power, that can be stored in the battery instead of wasting the power in the rotor resistance. So that we can say just we can able to improve the efficiency of the system, right? So here for charging application, just we are using only single switch. So by using the single switch, just we are charging the battery whenever the voltage is lesser than this, then at that time the this diode will be reverse biased, and it will it will stop to discharge the battery to the resistor. So that's what it will be, act as a self-regulating switch. So this is the simple topology. We are not incorporating many devices in it, or any charge controller or BMS, battery management system in it. By incorporating the simple diode itself, just we are using for battery charging application. Here the limitation we can say, because the absence of battery management system, we cannot able to look at the battery profile, the charging profile or SOC and all. So that's a disadvantage. However, just for making the system very simple, just we have proposed this topology. So this topology is very cost effective, and that's what just we have published this work in IET journal. So in this, just we have proposed some control strategy also. In the control strategy, just we are having the two modes of operation. One is constant output power mode and MPPT mode block. So here, depending upon the power demand, that means we can say it's a control signal. So depending upon the power demand from the grid, right? So this mode selector can select the mode of operation, whether it should operate in the MPPT mode block or in the constant output power mode block. So the decision will be taken depending upon the condition PD. So that's very important here. So here just you will get the 1 minute. So here you the control signal. So this control signal can given to the PI controller, then that will give the give it to the comparator. So by comparing with the carrier wave, we can able to generate the pulse for PWM pulse for the your chopper, right? So here the novelty is two. One is the unified controller. The unified controller means just this mode selector can decide whether your system should operate in this MPPT mode block or constant output mode block. So here, this is a one claim. Then another claim here is we can say just 1 minute, some call. Yeah. So here, another thing is in the MPPT mode block, just we have implemented the maximum power point tracking. So in the maximum power point tracking, just we need a speed information. So this speed information, we can get it from the speed estimation technique. So just we have proposed some new speed estimation technique. So to give the actual speed. So here, once you develop the algorithms, just always you have to verify with your experimentation. So that's very important. So that we have verified with that experimentation. For this, we have used TMS 320 LF2407 embedded DSP processor. So in this, all ADCs, DACs are integrated. So in this case, just we have given a feedback as stator voltage and rotor current. Stator voltage and rotor current, you have to give it as a feedback. So that algorithm I have given the future slides. So if you're really interested to work on that speed estimation techniques, just we can have a look at the paper. So we'll get the very detailed idea in it. So this is the experimental setup of wound rotor induction generator. And in the WF induction generator, just we have proposed the new topology, power electronic topology. Before going to that, I will explain the basic operation of the WF induction generator. So in the WF induction generator, just we are having the 4 modes of operation. So one is, the 2 are motoring mode, another 2 are generation mode. Normally in the wind turbine application, we have to use these 2 types of modes. So whenever your torque is negative, you can say the machine is operating as a generator. When the torque is positive, that's a motoring. So in a screw cage machine, we have known that during the supersynchronous speed, it will act as a generator, right? So here, if you want to overcome that, so it's a subsynchronous. So subsynchronous below synchronous speed always act as a motor. But if you want to make it as a generator during the subsynchronous speed, then that time you have to inject the power in the rotor. So that time, you can see here, the power is injected into the rotor. So that's very important. So during the supersynchronous is a normal generation. So that time just we are extracting the power from the rotor, right? So here just we can extracting the slip power and injecting to the grid. So here just we are drawing the power from the grid, or you can say it's the stator terminals that can be injected back into the rotor. So that time it will act as a generator, so that you can say you can able to operate the slip ring machine as a generator during the subsynchronous speeds, right? So here at the same time, supersynchronous motoring, in a supersynchronous motoring, then subsynchronous as a motoring, but just we are overcome that operation. So that time just we are injecting the power at the rotor terminals, right? So that's what we can say. You can able to operate your machine as a motor during the supersynchronous speed. So this is the 4 modes of operation in the DFIM, double fed induction machine, right? So in this, in a conventional system, if you look at that, there are two back-to-back converters. One is connected with the rotor terminals, and another converter is connected with the grid terminals. So in a in an electrical system, whenever we are having the converter at a grid side, it always injects the harmonics to the system. So that's what normally just we will avoid the connection of the converter to the grid. So in that case, that's what we have. Even any converter, even if you are having any power electronic switch in the system, obviously it will pollute the supply. So for that, we have to go with active filters and passive filters. So again, just we have to go with the design of the filters, right? So that's another design aspect. But for avoiding to connect the inverter directly to the grid, so just we have proposed some new topology. So why we have used the back-to-back converter means for a bidirectional power flow. So here, just we need some energy store. Just we can integrate some energy storage here. So by incorporating the energy storage, then the whenever the power required at the rotor, the converter can draw the power from the battery and it can inject to the rotor. So whenever the power available the rotor, that will extract, the converter extract the power from there and it send it to the battery for charging purpose. So whenever the excess power is available, that power can be used for charging the battery. Whenever just we are having the deficient power, then the battery can be discharged and it can be injected to the rotor, right? So that's what, by having this simple, we can say analogy of the bidirectional converters, just we have proposed some new topology for the DFIG system. So even in the literature, we cannot find the single converter fed double fed induction machines. So we are the first authors. Just we have proposed this kind of power converter topology for the double fed induction generators. So in this case, just as like your normal conventional DFIGs, just we are having the different modes of operation. So different modes of operation means depending upon the wind velocity, just we can divide the subsynchronous generation and supersynchronous generation. So during the subsynchronous generation, just we are injecting the power at the rotor. During the supersynchronous generation, just we are extracting the power from the rotor, and that power can be used for charging the battery. So here our main novelty is single inverter fed double fed induction generator. So earlier cases, just they have used the two back-to-back converters. So here just we have used the single converter. That converter rating also only the 30%, right? So this is the new topology we have proposed. So for that we have identified different modes of operation depending upon the wind power and the demand. So depending upon the demand and wind power. So that's whenever you are talking about the electrical system, just we have to ensure that the power balance should happen. So for considering that power balance, just we have identified the different operating modes. So in this different operating modes, just we have shown the battery power and energy in the battery. So how it's changing. So it's a typical, we can say, schematic by analyzing the system. So whenever you are proposing some system, power electronic system, just we have to be very careful that just we have to careful for analyzing the various modes of operation. So then only you can get to know the merits and demerits of that system. So just we have to put all extreme condition, and you have to test. You have to validate your proposed system. So that's very important. So the same way, just we have done for the proposed DFIG system also. So just we identified the different modes of operation. So due to the time constraint, just I can skip from here. If you want really work on this DFIG system, you can refer. This work also is one kind of IET paper in, I think it's in power electronics. So just you can refer that paper. So, or you can mail me. So I'll give that paper for you to further reference. So for this also, just we are, even in the literature, by reading the literature, we have come up with a lot of control techniques. So that control techniques gives us, I mean, we feel that it's very complex for implementation. So that's what our aim is for. We have to make system is very simple. So for that purpose, just we have come up with our own idea with a simple system. We can say it's a scalar control. So if it's a scalar means just we are having only the magnitudes. So for handling the magnitudes, it's very easy. So as compared to the vectors. So if you are going with the field-oriented control and all, then just we have to deal with the vectors. Then that is a complex in that systems. So that's what just we have proposed the scalar control. So it's in a synchronous machine. Just we are having the voltage control loop and frequency control loop. The same way, just one is frequency control loop, and another one is a voltage control, that voltage magnetic control. So by having the voltage, frequency control, just we can say you can control the active power. So by having the voltage magnetic control, just we can able to control the reactive power control. So this in that way, just we can able to achieve the independent control of active and reactive powers. So here, instead of taking the instantaneous values of stator voltage, stator current, rotor voltage, and rotor current, just we have in a system itself, we have generated the three-phase sine wave, and that three-phase sine wave can be used for SPWM purpose. So that's what we have done here in this work, and this work, just we have verified experimentally, and just we have published in some IoT journals. That's another paper. So here, same system. In this case, just we have worked for grid connected system, but here instead of grid, just we have thought of to connect only the loads. So how it operates. So just we analyze the system. So this will be the another IoT paper. So the thing is that what I want to convey here is just we can, when you are doing the research, just you can take the base work. Then after doing the literature review on that base work, just we can you can repeat this any one work of the paper. Then from that we can think of it, what are the parameters or what are the changes we can able to make it in the system. So then we can make the changes and you can analyze it. So once you are analyzing that changes, whatever you had done in your in the existing system, that will give you a lot of ideas. So that ideas you can write it down on the paper, and just we can go with one by one. So that every one point will give you the one research paper. So even just we have published in some good reputed journal like IET. So this is a good reputed journal. So just when I doing the first work, in that first work itself, we have identified the gaps. So that gaps we have noted down. So just first complete that work, then you can go to the next work. So then you can publish it. So in that way, if you are starting your research means, it will be very easy for you to complete your doctoral degree or postdoctoral degree. And it's not a postdoctoral, it's not a degree, postdoctoral research, right? That's what we are done. Just we are taking the slipping machine. Then from the slipping machine, just we have explored the different kind of techniques or topologies. One by one, just we have implemented, analyzed, and just we have done some experimental, and we have verified, and just we have published it. The same way, the same topology with a single inverter battery system, we have proposed for standalone system also. So in a standalone system, just as I told, if you are connecting the loads to the stator terminals, just we have to consider about the voltage and frequency at the load side. So just we have to use the voltage regulation and frequency regulation in this system, right? So here again, just we are not included any battery management system. So by monitoring the battery states, it's very difficult. But if you are taking this system to the system level, you can say some microgrid or smart grid level, then you have to incorporate these features. Then you can make the whole system as a autonomous system, right? So in that way, just your IoT will be helpful for adding the features into it. I mean, I'll tell you the simple, even the research ideas. If you're in the state of research, doing the research or PhD, then what you can do is you can take these all systems, whatever I have proposed in this distributed generation, you can take this system and you can add your IoT features. You may read kind of IoT features in the different systems. That features you can take up and you can put it in the existing system. Then you can start to work on it. So that can give you the one kind of objective for your research. So existing system, then we are taking some IoT techniques from some other paper, so that we can apply to your specific system. I can consider this as my system. You can incorporate that features and you can analyze that system. So that will give the one research paper. So in that way, it will be very easy for you to carry out the research, right? So here the loads, voltage and frequency control, so that we have implemented. So for in this also, just we have identified different modes of operation and just we have presented in our research paper. So here the heart of this work is control strategy. Yes, I already told you, even if you are taking the papers for power electronic controllers for DFIG, always they may discuss about the field-oriented control. So just we have, excuse me. Here, just we have proposed some scalar control. So in the scalar control, the advantage is just we can have the voltage and frequency, right? So in the voltage and frequency, just we are having the two parallel loops. So if you are having the two parallel loops, one for voltage and another for frequency, then just we have to take the feedback, that's the actual voltage and actual frequency. That how you are estimating that, that's very important. If you are having some kind of DSP processors or FPGA controllers, then just we can able to calculate or you can estimate the actual voltage magnitude and frequency by having the single sine wave. Just a single sine wave means just you can take the stator voltage waveform, instantaneous waveform. From that, by using the digital signal process, you can estimate the voltage magnitude and frequency. So here in this reference, voltage reference and frequency reference, if it's a three-phase, just you have to make 440 volt and frequency will be 50 hertz. That you can give it as a reference to your control loops. So here the PI controllers. So PI controllers can track your error. By tracking the error, it will give the control signal. So that control signal you can give it to the PWM generation. So here another novelty in this work is again for if you are doing the SPWM in the sinusoid pulse width modulation in the processor, then just we have to take the sine wave as a feedback. But here we haven't taken as a feedback, just we have generated our own sine wave by using the lookup table method. So that can be multiplied with the frequency. So that frequency will, this will decide the frequency of the sine wave, and here this will change the magnitude of the sine wave. So then that will be compared with the carrier wave. Then it will give the PWM. So that PWM you can give it to your devices. So here by why we have used this lookup table method for SPWM means if you are taking the feedback as a signal from the system, so in that sine wave itself you will have a lot of harmonics terms. So that harmonics terms again give the harmonics term in the signal. So again that will create the whatever the voltage you are generating from that inverter, again that voltage also will consist of harmonics. So if you are generating your own sine wave, that means pure sine wave. So whatever the voltage you are generating in a inverter also, it will be a pure without any harmonics. So that's what that's the advantage of this system. So just we have claimed as a novelty in our work. Again, just we have published in some IoT journals. So whenever you are proposing some controllers for wind energy or photovoltaic system, just we have to do some dynamic analysis. So that dynamic analysis means here it's a standalone loads. Then just we have to change the load, you have to change the input conditions, or you can change the references, and you can do the dynamic analysis. So for that, just we have done a step change in load and step change in input and step change in reference. Then just we have observed these quantities as experimental and simulation, and just we have compared it, and we have validated with the experimental results, right? Here the step change in speed. So if you are changing step change in input means just you have to change the speed, wind velocity. So if wind velocity changes, obviously your turbine speed will change. Then you can do the step change in speed, and you can plot these curves, right? So harmonics also within the limit as per IEEE. If you are connecting the distributed generation in the smart grid, that should be less than 5%, right? So that's what we have done. Then another we can say novelty in this work is just all people they have sorted the rotor, and that will act as a generator. You can use that slip ring machine as a generator. But here in our proposed work, one of the mode is just you can sort the stator. In a stator coil, the stator windings can sort it. Then just we can connect your converter with a battery that will act as a virtual grid to this generator. So here stator is sorted. So once the stator is sorted, then there is a possibility to flow the circulating current in it. So again, this will form the virtual grid to this machine. So just we are generating the power at the rotor terminals. So that will feed the power to the battery for the charging application. So that's what we will call this topology as a sorted stator induction generator. So in the sorted stator induction generator, just this is one of the mode in the earlier cases. So that mode itself we have analyzed very deeply by doing the analysis. Then again, this work again it will go as a one paper. So that's what we have done. So in this thing is again your IoT things comes into the picture. IoT things means just we are using the processor. So in this processor itself, by measuring the various quantities, voltage, current, and just frequency and everything, we can make the entire system as a autonomous. So that's what just we can say is a smarter system. So once you are incorporating your IoT things in it, then your system will be smarter. So in this way, already just we are measuring these quantities, right? Measuring these quantities for control purpose. The same quantities we can use for monitoring purpose, right? So that we are adding the features. That means just we will get the data. Then that data just you have to process it for which application you are going to use. So once you have done this work, that means adding the features, then your system will be smarter. Then you can say then your system will be efficient and effective, right? So here in the SSIG mode also, just we are measuring the voltage and frequency. By using that, just we have done some supervisory control. So again, the supervisory control is the application layer, right? So this is the application layer of your system. So here, the control algorithm is given. So how we are changing the modes of operation in the DFIG. So here algorithm, I will skip it. If you are working on this system, just you can refer this supervisory control, because for explaining this itself, it will take another 15 minutes. So just I'm skipping the, I'm giving the brief about the supervisory control. What is the purpose of supervisory control algorithm in the WFIT induction generators, right? So if you are having any doubts, please stop me in between. So no issue. You can ask me any question if you are having anything. Do you have any questions? So these are the experimental results. Just we have performed and we observed, and just we have incorporated here simulation as well as experimental results. That's what is a comparative stage. Just I mean, whenever you are doing the work, just you have to compare with your existing work. So that's very important. Why? Because if you want to climb your novelties, then just we have to compare with your existing system. So that's what we have compared with other wind generators as compared to PMSCs and school cage indexing machines. How our DFIGs are better, how our single inverter system is based on all is compared. And if you're then is a micro analysis. This is a macro analysis, and if you're coming to the micro analysis, then just we have to compare with your classical DFIG system. Already just we are having the back-to-back inverter system. So with the back-to-back inverter system, if you compare it, there is no energy storage. So you cannot able to do the self-starting. But in this proposed one, self-starting is possible. In earlier cases, just they have used the field-oriented control. So in that field-oriented control, just we have to deal with the vectors. So the control strategy is complex. But in a proposed system, just we propose the simple scalar control. Then another advantage is whenever, I mean, earlier cases, there is no energy storage device. So whenever we are having the excess power, just we have to, stop the wind turbine, or that excess power can be dumped into the dump loads. So instead of that, just we have the energy storage device. I mean, we have integrated the energy storage device so that we can able to do the some kind of energy saving, right? So that's another advantage. And there is, I mean, not much harmonics in the system because there is no converter directly connected to the grid. Only it's connected to the rotor. So in the rotor, you are having the winding. So that winding itself will act as a filter to send out all the current harmonics, right? And even there is no wind, then you are having the battery storage system that will be helpful for supplying your standalone loads. So that's what it's a micro analysis. In a macro part, as we said, its converter rating is only the 30%. And so if you are reducing the power converters, so just we are reducing one conversion stage. So once you are reducing the conversion stage, the conversion efficiency will improve, right? So that is as compared to others, this is the advantage of the proposed topology, right? So any questions up to now for power electronic controllers for distributed generation system? So same converter, power electronic converter controllers you need to use for photovoltaic system, or if you are taking the fuel cell system, then the fuel cell system, the advantage is just we are having the control over your source, the hydrogen supply, so that we can able to control in both the way, in the source side as well as in the load side. But here wind and photovoltaics are not in our hand. The solar irradiance or wind velocity is not in our hand. This is decided by nature, so we cannot control over it. So for that, just your control strategies would be very stringent to maintain the constant voltage and frequency in the standalone system. But in the case of fuel cell system, your hydrogen control is in your hand, so that will be very easy for you to regulate the voltage and frequency, right? So any clarification on this power electronic controllers? No clarification, no doubts. Any questions? No questions. Okay, then we'll move into the next topic, role of IoT in smart grid. So it's very important. Even we have discussed about basic, we can say if you're considering the smart grid as a system, the entire system, we have discuss about the some components. So we can say distribution generation is the one component in the smart grid. So now we have the idea. So if you are having the distributed generation in the smart grid, so how it plays in the system. So that you must understand now, right? By looking at the previous things. So that if it's connected to the loads, then voltage frequency regulation. And if you are saying it's connected to the grid, existing grid, then you have to do the active and reactive power control. And at the same time, if any fault happen, that will be sorted out. I mean, in earlier cases, it's a manual. So if any fault happen, just you have to isolate that portion and you have to do your own maintenance or own repair over there. Then you have to connect to your grid. But when we talk about the smart grid in a system, if you are making the grid smarter, if you want to make your power grid as a smarter, then just you have to incorporate some of the features in it. So that features, again, I'm saying it's a features. So just if you're having any kind of, for example, in our home itself, already just we are having the light, air conditioner, everything, but we are operating manually. So just if you want to make the smarter, so what's a kind of smarter? So where it starts smarter means, for example, once you enter into the room, then just you can use the motion sensors to turn on the lights. So whenever you are leaving the room, that automatically off. So this kind of semi-automation. You can say it's a semi-automation. So it's not full automation. So full automation means even the supervisor of that building, that supervisor can also take the control over the lights and fans. But here it's automated. Just you are using the motion sensor, and just you are once you enter it, if there is any motion in it, your light will be on. So it's a semi-automation. Full automation means even your supervisor, any person can sit, away from you, can able to control that device. Then that will be a full automation, right? So in that way, in a electrical power system also, just we are making the grid smarter for adding the features. So how we are adding the features in the grid means with the help of IoT, with the help of Internet of Things, that we can see. So that's what in earlier cases we can say the grids are passive. So if you are saying it's a passive, so whenever just you are sending some signal, or whenever you recur, that time just we can ask the person who are working on that location, and you get the information. Or in other words, in example, we can say in a system, just we are using the RFIDs and QR codes. So just by scanning the RFIDs, QR codes, whenever required, then you can get the information. So that is the passive. So when you are going to the active, so that active means, so for making the system active, just we need the communication. So we need a communication. So how you are communicate? So suppose if you are having the system, so if you want to control that system, right? If you want to control that system, how we can able to control? Is it possible? One way is open loop. So just we can give the order without getting any feedback from the system. Just we are giving the order and we are doing it in the open loop. So if you are doing in the open loop, whether it's effective, it's not effective. So we don't know the response of the system. We can simply sit and example here. I'm speaking myself without any feedback from you. Then there is no meaning of it. So that's what I'm keep on checking from you all whether you have any doubts or by your with the communication I can understand that how you are getting the things. So by that just I'm acting it, right? So this way of feedback is required. So how you are getting a feedback? So if you are having a system, so in that system you should have some sensors. So sensors, if you are having the sensors, then sensors will give the information. So based on the information from the sensor, then you can able to operate. So another thing is automation. So just we are adding all the senses. We can say it's seeing and touching and all the senses you are adding to that, then your system will be active. So awareness. So how you are getting an awareness means, for that creating the awareness, just you have to do some kind of calculations. Just you need some data in your system. So by analyzing the data or by doing some calculation with the data, then just you can do the response, or you can say, for example, IVR systems. So just if you are typing any word, so based on that word will be searched in the database. Then that will give, whatever the data is available related to that keyword, that will be given to you, right? So the same way, the best example is telehealth and autonomous system. So autonomous system means even just we are making the system more smarter. So here, best example is autonomous cars and smart grid. So in autonomous cars, just nowadays we are talking about driverless cars, and even the machine-to-machine communication. So even your cars itself can speak themselves and can take the decisions. So just it's a decision making in autonomous system. The decision making is very important. If your car is making some wrong decision, it may go into some wrong way. So in that way, your decision systems would be very effective. So for making the decision, nowadays we are working on the artificial intelligence and machine learning, right? So that artificial intelligence and machine learning techniques will play a major role in the autonomous of the system. So that's why whenever you are taking the smart grid, there is a autonomous system. So even the grid itself, the machine itself can take the decision, right? The machine itself will take the decision. So that's what we are making the grid smarter. So these are the popular fields in IoT application. So in this list, you can see here, normally people are more talk about the smart homes, right? So smart home, the IoT application is majorly used in the smart homes. In what way we are making the smart homes means, just we can make all the gadgets in your home is smarter. So even light, fans, just we are having the refrigerator, washing machines, just we are having the TV. So these devices can communicate each other and they will take the decision. So that decision, how they are making the decision. What's the purpose of going smart homes? One is, as I'm lazy, so I cannot able to go and switch on the lights or fans. Just earlier we have used the remote controller. So nowadays, just we are having the apps. Even always we are carrying the mobile. So in the mobile, just there are a lot of apps. So by using the app itself, you can able to control your fan. Even I'm lazy to search my remote controller. So for that, just I'm using the mobile. Then from the mobile itself, I can able to control my fans or my washing machine or for my air conditioner. Even before reaching the home, just I want to on my air conditioner. So for that, just I can when I start my car to my office, so that I can I can send the signal so to turn on the air conditioner, so that you are communicating with the devices or gadgets. So that's possible in the smart home. So just that will make the life easy, as well as will make you lazy, right? So I don't. This is a comment I heard from one of the experts. So that's what just I'm saying. So these smart gadgets can make your life easy, but sometimes it may makes us the lazy. Even not only you or me, for everyone, right? So this is in the smart home. And another thing we can say, what is a major advantage? Here always we talk about the negatives. So by having the smart home, we are having the major advantages. So by having the smart home, you can, I mean, even some case study says that you can able to reduce the 40 to 50% of the energy consumption. So if you are having the variable tariff in our country, there is a possibility by having the, there is a possibility to reduce 50 to even we can say 40 to 50, at least 40 to 50% of the energy saving. So that's possible because I mean, even the machines just that itself will calculate the things, and your turn on your washing machine, turn on your air conditioners. Whenever you can say if you are having the variable tariff during the morning hours, the tariff will be higher. That means peak hours, the tariff will be higher. So during the offload period, you can able to turn on your washing machine or dishwasher and all. Then you can able to save the energy. During the off-peak period, the tariff of the electricity is lower. So that time, if you're on, if you're smartly on these devices, you can able to reduce the electricity consumption, so that it will save the energy as well as cost, right? So next, in the next place, we are having the wearables. So wearables means nowadays just we are talking about watches, wristwatches, mobile phones. Even just we are having the smart gadgets like music gadgets, or a lot of wearables are there. So nowadays people are making these wearables as smarter, right? So even cameras, everything. Then the next application of IoT is smart city. Nowadays, just we are talking about the smart city. So again, the smart city, just we are having the different energy resources, like you can say water, gas connection, water connection. Just we are having the safety. So everything is possible with the IoT devices. Then here smart grid. So next application, the big application of IoT is smart grids. So that's what we are making our grid infrastructure as a smarter. So that is another place. So when we talk about the power, electrical power, then IoT application is playing the huge role. So that's what we can say. Just we also need to know some kind of computer science stuffs to survive. That means as a professional, I'm saying. So just we have to talk. You must be having the knowledge on the communication, even the communication protocols, or just you have to know about some kind of computer stuffs, organization and everything, right? So then another is automotive. So in this, connected cars also plays a huge role. So why they have listed this application means, so if you look at this, all the applications up to 6, so these areas having the huge potential. That means revenue making. If you are going with the background of it, by having the IoT applications in these devices, in these applications, you can able to make the revenue, huge revenue. So that's what people are looking for, the automation of these areas, right? So so that's what even our at the same time, if you look at all these areas, so what is the major thing? Electricity, the electrical power. So just here, power consumption, or just reducing the cost, the running cost, and all, it will be possible in terms of energy. In terms of energy, you can say it's even the power consumption also. So that's what you can say. We are concentrating much. That's what we are having this short-term course also, this IoT application in the smart grid. Okay, why this smart grid coming into place means, nowadays we are due to this manufacturing of the sensors, just we are having technology, we are getting the cheap sensors. So that means the sensors cost also coming down day by day. So for placing these sensors in the system, it will be very easy, right? And another thing is bandwidth. Even just we are having a lot of bandwidth, so we can have the easier communication. So that is possible with low cost bandwidth. and processing techniques. So nowadays, even for 50 rupees, we are getting the processors. So processing the data, processing the process itself, it's very easy nowadays. And even everyone having the smartphones with internet connections and wireless coverage. Again, because of the smartphones, just we are getting the wireless coverage in a getting cheaper. That's what the telecom companies are going to bankrupt soon. So that's what they are planning to hike the tariffs now. Even the Vodafone, ATAL, and Jio, even the Jio, for business purpose, they are given a free. You can say is a free data. So because of that, other competitors are struggling. So, however, soon they are going to implement the higher tariffs. Okay, another is big data. So because of this sensors, bandwidth, processor, always we are getting the data from the system. So how efficiently we can work on this data? So nowadays there are a lot of technologies, the machine learning is coming into place for the handling this data. So it's another area, big data. Okay, so now we'll move into the smart grid. So what is smart grid? How we can make the smarter means? So even if in a system, even our system itself, if you communicate to all, then it will be easy for you to make us as a smarter. So the same way in a grid also, just if you are adding the communication between the devices, so that will make the system smarter. So that's what network that can connect any object with the internet based on a protocol for exchanging the information. So just we are exchanging the information from one device to another device, then just we can able to get a lot of you can say information. So based on the information, just we can take the decision also. And communication among the various devices, right? Communication among the various devices for monitoring. That means you can able to monitor everyone in the system or every devices in the system and track. Even you can track, suppose if I want information about any connected devices here, so I can able to even the I can able to communicate to the end user, so I can get the information from them. So information, as well as I can able to track how he's working and all, just I can able to track from here. And management. So just we are in this system itself, by looking at this, you can say it's a centralized control, but it's not a centralized control even for every system. But this is the in a hierarchy, this is the most top one. Then after this one will be there. So this one will take care of the bottom one. So just we are having the hierarchy control also. So that means just we are having the distributed control as well as centralized control. So whenever this centralized control needs to access this, even he can able to act, as a that's what I can say. In your organization, director can access the deans can access the faculties. But whenever the director need to access the faculty, it is possible. He can overcome this dean, then he can able to access the faculty. So in the same way, just we can do the communication. So for that, management also it's possible. And location identification. So that means just we can able to track where this devices are located and how it operates and all. It's possible in the IoT, Internet of Things. So that's what just we are very much interested to incorporate these IoTs in the smarter grid with these three main concepts. So in these three main concepts is a things oriented. So things oriented means, so whatever the devices in your electrical grid, I can say in a distribution network, you are having the smart meters, you are having the PMUs data also you can able to access, and the PMUs can be connected at utilization side as well as in the GenCo side. So that devices will be interconnected. So the devices and internet oriented. If you want to communicate to the GenCos or other devices, then you have to connect it with the internet or with the network. Then software, just on the top of it, just you should have some kind of GUI for monitoring, right? So again, just the software also plays a major role in the smart grids. So that's what in this picture we can clearly understand that in earlier cases we can see here the generation, transmission, distribution. So there is no communication here, but nowadays just we are having the communication at each side. So in the generation side, just we are having the communication. In the utility side, we are having the communication. So this will be sent it to the network. So the network can able to communicate to each devices. So just we are merging the communication with the energy network. This also is a network. Communication also is a network. Just we are merging these together. Right? Yeah. This way. Just we can merge it, and finally just we can make the grid as smarter. So computer science come into the place with the electrical engineer to make the grid smarter. Yeah, there are a lot of definitions for smart grid. So as per US Department of Energy, they are giving some definition for a smart grid. So smart grid will be considered as an intelligent grid. So if you say it's intelligent, just you are incorporating the intelligence to the system, so that that will make an intelligent grid that integrates the technologies of advanced. I mean, if you are making the intelligent, your sensing should be very efficient. So just we are incorporating the advanced sensing and control methodologies. So precise control, and just we are having the very fast communications into the current electricity grid in transmission level and distribution level. So just we are incorporating these technologies into transmission and distribution level, then your existing grid will be a smart grid. I mean, by saying this word, it will be very easy. So when we are coming to the field, just we have to face a lot of difficulties and challenges. So when we are having this challenges we'll discuss in the last slide. And here, once you are making the grid smarter, then for monitoring, analysis, and control is very easy. So in that way, that's what just we are focusing on the smart grid. Okay, so here the thing is that just we are incorporating the communication system into it, and we are making the grid smarter. So this smart grid is considered as one of the largest application of IoT. So that's what we are focusing much. So if you're saying it's a smart grid, that grid that makes decision. So it takes the decision themselves. If makes decision themselves means if you're having any kind of power imbalance in the system, then just we have to take the decision to turn on any kind of power plants or turn on any UPS system in this system, or any energy storage may come into the picture. So just we are having the decision power, so that just we can able to do some kind of energy management system in the grid. And sensors, yeah, sensors means so every information will be communicated to the every part of the system. So that's very important. So how you are sensing means already just for example, in the morning we have discussed about the power electronic converters. For control purpose, we have measured some of the quantities like voltages and currents. So that voltages and currents you can send it to the centralized unit. So just we are collecting the data. So I mean, in addition to the existing sensors, just we have to incorporate some more sensors. So earlier case, if you want to measure the power in your home, then you have some kind of gadget. You have to take the voltage and current, and you have to do some calculation and all. But nowadays you are having the smart, smart meters. So that smart meter itself will calculate everything, and it will have the data, whether it's a power factor, active power, reactive power, power factor, and then phase balance. In each phase, how much voltage, in each phase, how much current you are drawing. So every data you are having. So that how it happens means by sensing, right? So this smarter grid will act as a clean and green. Clean and green means, so if you are having the, for example, I can take just we are having the more wind power and the power from photovoltaics. So that time, just we can utilize that powers by cut off your conventional power plants. So that also, because it's having the decision power, so it will send the control to the conventional power plants to reduce the power. So that also it's possible. So it's possible, depending upon the forecasting of that wind photovoltaic, it's possible to make the grid as cleaner and greener. And as we say, this operates efficiently. So whenever having the demand, the turn off your sources. So whenever just we are having the non-critical loads that will set up whenever the emergency occur. So that in that way, you can say it operates efficiently. And finally, by incorporating this big data and machine learning techniques, you can make this grid as autonomous, right? Just you can make this grid as autonomous. That means autonomous means it takes a decision, right? By using the intelligent techniques. So that way, just you can able to make the grid smarter. Then here, what are the features of smart grid as compared to the conventional grid? So we can say self-healing. So just if you are having any fault, it happen. So your, your smart grid itself will act as a one kind of mini robot. So that heal itself. That means just you can find the fault location and it will isolate and it will operate. So whenever fault is clear, then it will synchronize with the grid. So that type of self-healing is possible without any human interference in the system. And because human always require the human to operate it, but we can able to reduce the human interface. That's exact word here. Yeah, it will again when you are making the system, again just we are having the lot of cyber security issues. So just we have to make this system cyber attacks free. That we have to take care. By incorporating some kind of cyber security techniques, just we can make it. And here, active participation by consumers in demand response. So demand response already we know. So even the consumers can participate in the smarter grid. So by turn on and turn off your devices, just we can able to do the peak saving or value filling and all. It's possible with this demand response. So that is automatically possible in the smarter grid. Here, just we are developing algorithms and we are doing manually, right? So here, accommodation of all generation and storage. That means, okay, if you are having the storage, storage means earlier just we have one big we can say energy storage devices that may be put it in the system that will be considered as a central storage system. But nowadays we are having the EVs, even we are in electric vehicles. In electric vehicles, we are having the battery. You can think of it, all electric vehicles are connected to the network. So we are connecting the battery to the network. So by having the smart grid operation, you can even you can able to control that individual batteries. As a if discoms are there, discoms can able to connect all the batteries and can calculate how much of energy it's available in the network. So that and all is possible with the smart grid. And new electricity markets. So new electricity markets means if you are having the variable tariff, I can say when a variable tariff during the peak hour, your electricity cost is higher. I can say it's 10 rupees. During the off-peak period, your electricity cost is 2 rupees. Then what I can do is, as an individual, I can have the big storage, right? Battery energy storage. So during the off-peak period, my cost is 2 rupees. Electricity cost is 2 rupees. By using the 2 rupees, I can charge my battery, right? I can charge my battery, and during the peak period, the electricity cost is 10 rupees. So that time I can sell it to the grid. So just I can make a profit out of it by having the energy storage with me. So that kind of new electricity markets and all, it's possible in this smarter grids. Even everyone can participate. Even as an individual, I can participate in it. Then optimize the asset utilization. So that's what. For this, just you need not to spend much infrastructure costs in the system. So whatever the resources is available, just you can optimize it and you can utilize it. So that is possible in the optimum utilization of the resources are possible here. And quality power, yes, 100%. Even if I mean, during for example, I'm in a critical condition. Just now I need electricity compulsory because I'm giving the online lecture. So I need electricity. So this time I cannot compromise without electricity. But if I consider this is a peak period, I'm ready to pay for higher cost. So I can pay higher cost and I get the power now. So during the peak period also, I'll get the always 24/7 I connect it to the network. But depending upon the situation, the price of the power will change. And as a consumer, I'm satisfied that I'm getting the power whenever it's critical condition. And quality power means, again, by having this incorporating this communication, then just we can able to reduce the power quality issues in the network. So power quality issues means, suppose if I'm connecting any power electronics loads at my user end, so if you are having the control over it, I can able to the GenCo is able to control the load itself. Even I can disconnect whichever the load's making a disturbance in the system, I can disconnect that one, right? So that is possible. So in that way, just so you can improve the quality of the power. So here, the operating efficiency. So whenever we are talking about the operating efficiency, so just by having the optimum utilization and by operating that devices effectively, you can achieve the better operating efficiency in the smart grid. So these are the features of smart grid. So here, this is a smart grid paradigm. So just you can say, in an earlier power system, as I told you, just we are having the generation, right? And transmission, distribution, and consumption. So this is the earlier flow. So now this distributed generation, I can say distributed generations are connected here. So now I can move this distributed generation to here. Why? Because if I have the distributed generation here also, I can able to communicate with this distributed generation. So I can group it here, and just this is the flow it happens. So power generation, just you can say it's step up, and it's transmit and distribution. So for that you need a step down transformer. So just we are having the gateway. So this gateway will collect all the information from the loads and can communicate to the GenCos, or you can say it's the discoms. It's available in the discoms itself, so it will communicate to the GenCos. So here in every home we are having the smart meters. So from the smart meters, this gateway will collect the information. So here, this is the power flow, right? But here, if you look at it, this is a one-way communication. Now, if you are having the smarter grid, just the consumption and distribution having the two-way communication, because in the distribution network, we are having all the distributed generation sources. So on top of it, how we can integrate the communication? That's very important here. So how we can make it means, just again we can divide this communication area like this. So whatever the communications happen in this consumer side, that I can say is a home area network, HAN. Then whatever it happened up to the distribution level, so that will be called as a neighborhood area network, NAN. So NAN, neighborhood area network, and here is a home area network is a HAN. And whatever is happened here, the larger level, so that's a WAN, wide area network, right? So here, if you look at that, the information flow in all the sites is a bidirectional sign. But here the power flow is in a unidirectional, but here is a bidirectional. But whenever look at that communication flow, all are in the bidirectional side, right? So that's what you can say. If I say it's a home area network, just you are having the smart meters, energy store. I mean, in our home, just we are having energy storage devices, and you can say on a home, just we are having the rooftop TVs. So the information about that rooftop TV is also available in the HAN. So here, when we talk about the energy storage, we have talked about only the battery storage. Even this refrigerators, air conditioner also will be considered as a it's a mechanical storage systems, but it's not double way. I mean, you cannot do charge and discharge, but we can do the charge. Discharge is not possible. But if you're having the battery storage systems, then charging and discharging is possible, right? And then in a neighborhood area network, just we are having the data concentrators. So that's available here in that node. And even we are having the PMUs and all. So in the PMUs, you can able to communicate. I mean, you can have the data, so that data can be shared to all the devices. Then just wide area network, just we are having the main control centers in the Genco side. That's what when we are talking about a HAN, the application of HAN is, so just we can say is a demand response management is possible. At the same time, you can able to forecast that irradiance and forecast the wind, wind velocity and all. Then you can do the energy saving at the consumer side itself. So energy saving at the consumer side itself, it's possible. Even if you are having the EVs, so EVs come into the picture, then for EV, I mean, just you can get to know the status of charging and discharging of the EVs and all. It's available in the home area network. So when we come into the NAN neighborhood area network, so here the distribution level network. So in a distribution level network, just we can predict, forecast, or predict the abnormal situation and act accordingly, because just your grid is smarter. So just you can predict the situation and act accordingly. And smart patrol. Earlier days, just we have the manual patrols for finding the faults and clearing the faults and all. So now once you are having the network here, then it will be easy for you to identify the fault location and all, and you can clear the fault and you can connect your system to the network. And wide area you can say it's a wide area network. It's in the transmission tower production, and it will be useful for online monitoring of the transmission lines. If you are having any fault happen in the conductors or any temperature rise in that transmission line, then you can easily able to identify by using the WN network. At the same time, islanding of the one distribution network. If any fault happen in the the transmission is connected with the multiple distribution network. If any fault happen in the distribution network, you can isolate it and you can able to island that system and you can operate it. These are the gateway integrations in the smarter grid. So in a consumer side, just we are having the IoT gateways, and for you can say in the distribution side, just we are having the server. So that server can be communicated to the utility side main servers. So it's a both-way communication. So for taking the decision or monitoring, even the metering of every part of the consumer, just you can say it's a demand response at the distribution side. it's and all it's possible with this in that way of integrating the gateways. Just we can say by having that IoTs, just how you are making the system smart means just just we are having the WAN. So in the WAN, it's connected to the generation side, power generation, and power transmission side. So that's what's connected in the both the sides. In the power generation side, just we can able to make all this kind of tasks, and in the power transmission side, just we are having the smart patrol, smart distribution, production, everything is possible. And when we are coming to the HAN, is HAN side, you can do a lot of work as a consumer side. That's what the smart cities and smart homes is coming to the picture. So that's what you can do a lot of things with the home area network. So that's what in IoT they are focusing much on the user side. So user side, you are having a lot of application of the IoT. So you can say it's a smart cities, smart home, smart buildings, demand response management, even the meter reading, billing, everything is possible with the HAN. So that's what this we had discussed. Even if you are talking about a smart grid and smart city, so we cannot, individually cannot say anything. But if smart grid is there, then smart city is also is easy to implement. So that's what just it's clubbed together. So in this smart city itself, just we are having a smart building, home, smart energy, smart water, smart transportation, and smart public services, and even just we are having the irrigation, everything, and even agriculture also we can do the irrigation, smart irrigation systems. So that and all is possible in terms of smart city. And smart grid, as we discussed, just we are having a consumer side, distribution side, and transmission and generation side. So already we have discussed this thing. Yeah, in a building itself, we are having a lot of nowadays. We are having a lot of gadgets to make our home smarter. Even the security, even we can say it's a smart lighting system, smart air conditioning system. Everything is possible. So that too, we can by having the HMI, human machine interface, you can able to control every gadgets or every devices in your home remotely. Even the major drawback is cyber attacks. If any cyber attacks happen, then the control of your home will go to the another person's hand. So that will be very dangerous, right? So even by making your device malfunction, you can able to damage your house. So that also is possible. So active grid management, that means by having this IoT, what are the benefits? So condition monitoring. So by doing the condition monitoring, just you are, you are protecting your equipments from the hazards. So asset optimization, so that assets will not be damaged. And demand response management. So just we are making the virtual power plants, like if you're having the, if your EVs are connected to the network, so you can take all the batteries and you can make it as a one virtual power plant. And feeder monitoring, voltage and everything. So capable to manage the fault and voltage optimization and frequency optimization, and all is possible. Substation monitoring, by having the substation monitoring, you can able to do the load balancing. So by having all this, just you can say you can have the very secure and manageable and connected network. So that will be called as a smart grid. So that's a future, and a lot of work is going initially on that grid side to make them smarter. So these are the things I would like to convey. So when we come into the challenges, again, just we are having a lot of data, right? So just we have to take the respective data for our analysis. So that's what it's a big data will play the major role. And security is a major issue. So if any cyber attacks happen, control of your home or control of the network in your enemy's hand. So you can do any kind of damage to the system, because if they hack the power grid, that's it. Your entire nation will be outage. So if it's outage, every services will be blocked. So there's a major security issue with the smarter grids. That and all. That's what the person who are dealing with the cyber securities, they are having the huge opportunities to work on the power grid side. And budget limits, and even every country having their own limitations. So the allocation of the budgets for making the grid smarter, so that's another question mark. It's depending upon the government. At the same time, we cannot able to predict the demand. So that's a big bottleneck in India. We cannot having the control over the demand. So that and other challenges are involved. So how we are having the infrastructure, power infrastructure and all, it's another question mark. So these are the challenges in the smart grid. So in this slide, I stop here. If you're having any clarification, just you can post your question. I hope I have stopped at correct time. So thank you for your patience. So if you're having any questions, please let me know. Or if you're having any questions, you can later also you can write it to me. I think your coordinator had shared my communication details to you, so we can communicate. No issue. As of now, if you're having any questions, I'll be happy to take up the questions.
Hello.
Hello.
Can you hear me?
Hello.
Hello.
Yeah.
Can you hear me?
Yeah, please.
Yeah, my question
hello,
is this: IoT based when IoT will introduce a smart grid,
Okay.
what will its impact on the conventional transmission line protection, distance protection, and on different categories?
Sir, that's what. Even that protection, everything will be in your hand. Here, on top of it, just we are putting the another. I can say it's a some layer, network layer on it. So even distance
It
laying
will
and everything.
only collect data, or it will play on
No, it
protection?
collect the data, also play with that relays.
Because because distance strategy is different in 2 and 3 step characteristics, move and like that, different characteristics
No.
by voltage current.
Yeah.
Hello, sir.
That is possible. On the top of it, you are having the communication layer. I think your voice is not clear for me.
Yeah.
Hello.
I am from Gujarat, so maybe communication is not good from this side.
Okay. So
Hello.
in the distance relaying also it's possible. I mean, what I want to convey here is already just we are having the control on the top. I mean, that we can consider as a primary control. On top of it, we can take the secondary control. So that secondary control can able to communicate at the same time. Just your network can have the access of the control of the devices. That's possible.
Okay.
Hello.
Yeah.
Hello.
Yes.
Hello, sir. This is Jitendra Managre from Sri Vaishnav Vidyalaya, Indore. Can you hear me,
Okay.
sir?
Yeah, please.
Sir, my question is it only a proposed methodology or it has been implemented?
No, it's not implemented. Even the developed countries also, it's not at all implemented. I mean, still it's in a semi-automation level. So that's what people are looking for. Already they have some kind of pilot projects. Project means it's a small level project. So now people are looking for the field implementation. So for that, that's what the budgets and everything. It's a matter here. So that's what there is no practical smart grid. It's available. It's not available, but we are having the pilot projects on it.
Okay, sir. So, what are the more aspects to be included in this type of methodology, sir?
And that's what you can. I mean, you are having these features. That's what no. Even from the each and every device levels or component levels, you can add these features, this IoT features in it, and at last, no, you can take all the data and you can able to implement it. So at a single stage, you cannot able to implement it. So just you have to take from every device level, then you can go step by step. That is possible.
Okay, okay.
So first we can do, we can do home automation. Then first do home automation. Then we can go with the system level automation or distribution level automation. Then after that, you can go with the system, entire system level automation. So that's possible.
Okay, okay. Sir, is there any research area on this topic of, sir?
Yeah, you can have a lot of research area in this. So whatever the, work you are doing in the networking and all, just you can take that, that methodology and you can implement in the smart grid. So what are the data? I can talk about the phasor measurement units. I can talk about the distribution level, even the smart home. For example, one of my scholar is working on the smart lighting system. So that itself, it's kind of application of IoT, right? Application of IoT in a smart grid. So when I consider the entire system, that's a smart grid. If I consider my home, that's a smart home. So that smart home is one part of the smart grid, right? If you're making your home smarter, then obviously just you are making this, at the system level, it will be very easy for you to make the system smarter, right? So in a smart lighting system, just you can do a lot of sensors are available. So instead of using any sensor, you can use your even I can say surveillance cameras. That surveillance camera itself you can use for multiple purpose. I can use it as a sensor, and I can able to control the lighting in the building, right? So by doing that, you can able to save the energy in the building. So once you are saving the energy in the buildings, obviously it will be good for when we are discussing about the system level.
Okay, thank you, sir. Please share your PPTs with us, sir.
Yeah, sure.
So that we can read it in deep.
Yeah, sure,
Okay,
sure.
thank you, sir.
Yeah, welcome.
So Mr. Sundar has asked any further information about DSM using IoT, sir.
Sorry, ma'am.
In the chat box, Mr. Sundarajan has asked any further information about DSM using IoT.
Yeah, it's possible. DSM means that's what again I come to that is a demand side management. So in a demand side management, what we are doing, just we can say it's value. In a DRM, the demand response, value filling or peak saving. So here for value filling, peak saving, what will happen in a home? What I can do is, so I'm connecting all the gadgets. You can say all the refrigerators, air conditioners. You are having the lighting. Suppose I need a light more. If I switch on my air conditioners, that will give the disturbance, or I can say during the peak hour, if I switch on the air conditioner, that will give the higher cost, right? So that time, what I have done, just manually I'll go, if it's 8 o'clock, I'll manually go and switch off my air conditioner. Instead of that, just if you're having the IoT, so even your discom can able to operate your load. Am I right? If you're having the good communication between your home and your discoms, the discoms can able to access your load. So that if you're having any kind of optimization technique, that itself will send the control signal to your air conditioners to turn off. So that automatically will turn off the air conditioner. So that time you can able to save the your cut down the demand, so that you can able to balance the power, right? So that and all is possible. There are a lot of things you can do it. Only thing is that I will tell you very simply. Here you should have the multidisciplinary nature. So you should have some idea about the IoT things, what's happening in the computer science side, and what's happening in the power system side or in the electrical system side. So just we can integrate these two futures. Suppose if I'm doing a DSM DRM here in a power system, So I should know some kind of communication protocols. I can know some kind of supervisory control algorithms. So by embedding this supervisory control algorithms into the system, I can make my DRM DSM is smarter. So it will be a good work. There are a lot of opportunities.
Any other questions or feedbacks?
Sir, is there any country where in microgrid, DC microgrid, IoT is used for protection?
I'm not getting, sorry.
Do you know that? In any country, is there a IoT based DC microgrid available or not?
Sir, DC microgrid itself, it's a evolving technology. I can say when we come into the DC microgrid, when we are going for DC microgrid means for only the low voltage levels. So for medium voltage, we won't prefer the DC. Only we prefer the DC for low voltage level as well as HVDC systems. So for low voltage level means I can consider my home. So for for home energy management system, I can go with a DC grid. So in this case, again, these are pilot level projects. There is no standard or there is no guidelines for this DC grids. So it's keep on developing. There is no commercial systems on the DC microgrid level. So in this itself, in this itself, you can have. That's what I told you. If you want to make us lazy, just we can incorporate these features. That's what. Earlier, just we used remotes. Now we are not using the remotes. Just we are using the apps. So why? Because that's what. Even you can see in the ATAL and ATAL DTH and all. They are coming up with the set-top box with the extreme box. In that just in the mobile itself, you can have the app and you can able to make your mobile itself as a remote. Otherwise, I have to search my mobile, right? Search my remote for control. Now, always I'm having my mobile in my hand. So by by opening the app, I can able to control it. That's what. The DC microgrid also, just we can add this feature. Just adding the features. Existing systems are there. Whatever the features or whatever the system you want to make smart, add the features that will be make it smarter.
Yeah. Okay. Thank you.
Okay.
Thank you, sir. Thank you for this wonderful forward-thinking, very innovative session, sir. We got to learn a lot about IoT and a smart grid, sir. Thank you for spending your valuable time with us in this FDP in the morning session, sir. Thank you for your efforts. Thank you, sir.
Yeah, thank you, ma'am.
Thank you, sir.
Thank you all.
Participants will be posting the feedback link in the chat box and it will be open for another 1 hour. You can fill that. Thank you. Thank you for your patience. Thank you for participating. The next session will be about 2 p.m. Thank you.